Hello everyone. So let's discuss the third problem of today's weekly Leetcode contest. Find palindrome with fixed length. So we are given an integer int length and we are given some queries. For each query, we need to find that smallest palindrome of length 3. So for example, if query is 5, we need to find the fifth smallest palindrome of length 3. And similarly here, query is 4, so we need to find the fourth smallest palindrome of length 4. So let's try to understand this with an example. Let's say the length is 2 and these are the possible palindromes of length 2. Now, if let's say query is 4, then we need to find the fourth largest palindrome, which is in our case 44. So we'll return 4. Similarly, if query is 9, uh, ninth smallest palindrome is 99. So we'll return 99. And if query is let's say 19, then we can say that there's no palindrome. There's not 19 palindromes are possible with length 2, so hence we will return -1. So hope the question is clear. So let's try to understand the solution. So before jumping into the solution itself, let's uh, try to understand a few things. So for simplicity, we are just assuming that the length of string is even. So the odd case is very similar, but we will come to that afterwards. So we are assuming that the length of the string is even. So like if the length is even, we are sure that whatever we'll put here, the same will come here, and whatever we'll put here, the same will come here because this has to be palindrome, right? So in a way, we just need to fill the first half. If we just fill the first half, the rest of the other half is just the mirror of this first part. So what are the number of palindromes that is possible? This can be filled with anything between 1 and 9, right? And this can be filled with anything between 0 and 9. Why 0 is not possible in the first place? The reason being, let's say if we put 0 here, the palindrome will look like something 0 2 to 0, right? And this is not of length, this will be of length 2, which is not equal to 4. So that's why we can't put 0 in the first place. So the first place will always start with 1, and the inner positions can start anything, like we can put anything in the inner position starting from 0 to 9. So with this, let's try to uh, devise some solution. So we will just perform the same kind of operation that is given to us. So let's say we have put 2 here. So what does it mean to put 2 in the first place? It means that we have already skipped all the palindromes that is starting from 1. So we have skipped all these 10 palindromes already. If we decided to put 2 here. Similarly, so if we put 3 here, we have already skipped 20 palindromes. So if we put 3 here, we will get any palindrome starting like 21st to 30th palindrome if we put 3 in the first place, right? So with that, let's try to iterate over an example. Let's say we have to find 234th palindrome of length 6. So let's increase a length by 1. Now, uh, let's say we need to find the 234th palindrome of length 6. So what we will do, let's start with the list. We will start with 1 here. So remember, we can't put 0 here because this is the first digit. So we start with 1. If we start with 1, what are the palindromes? Like how many number of palindromes are possible that will start with 1? 100, right? Because uh, we have 2 digits to be filled, and each of these are inner digit, so they can have anything between 0 to 9, and hence uh, 10 into 10, which is 100. So there are 100 possible palindromes that is possible if we start with 1. But we need to find 234th palindrome. So clearly we can't start with 1. So we have to, like, if we put 2 here, it means we have already skipped 100 palindromes. So previously we have to find 234th palindrome, but we have already skipped 100 palindromes uh, by deciding that we will not start with 1. So that's where we have to now find 134th palindrome. Now, again, starting with 2, how many palindromes are possible? Again, 100. Like there are two places and both are inner places, so they both can start with 0. So total 100 possible palindromes are possible. Again, 100 is not 134th, so we can't put 2 here. We have to put higher digits. So if we put so we have to put higher digits. So if we put 3 here, it means we previously skipped 100 by not putting 1. Now we have again skipped 100 by not putting 2. So now we have to find 34th palindrome, right? So let's again devise like how many palindromes are possible if we start with 3, again 100, and we have to find the 34th palindrome. So 34 will lie within this 100. So that's why we will fix the first digit with 3. So the first digits the first digit is now fixed, like 3 is the first digit. uh, Now let's try to find out the second digit. Again we will do the same thing, we will start with 0. Like remember that you can start with 0 now, so if because this is an inner digit. So if we start with 0, how many palindromes are possible? 10, because there is only one digit to be filled. So 10, like 34 is not in 10, so we can't put 0 here, we have to put 1. We can try 1, but before trying 1 we will subtract 10 from this, because we have already skipped 10 palindromes by not putting 0. So if we try 1 here, we will again skip 10 palindromes, right? Like we can form 10 palindromes, but we need to find 24th palindrome. That is not possible with 1. So again 1 is not the right candidate. So if 1 is not the right candidate, we can't put 1 here. We have to try 2. But before trying 2, we have already skipped 10 palindromes by not putting 0. And we have again skipped 10 palindromes by not putting 1. So total, now we have to find out 14th palindrome. Okay. Now if we start with 2, again 10 palindromes are possible, but we need to find out the 14th one. So that is not possible. So again 2 is not the right candidate. We have to try something else, let's say 3. But before trying 3, we have to subtract 10 here, because we have already skipped 10 more palindromes by not putting 2. So now we have to find the fourth palindrome. Again with 3, 10 possible palindromes are possible, and we have to find the fourth one, which is in this range. So we will fix this position with 3. Now let's try the last position, try filling the last position. Now with for last position, again we will start with 0. Now if with 0, one palindrome is possible, because there is nothing else to be filled, right? So one palindrome is possible. So this is the first palindrome, but we need to find the fourth one. So clearly 0 is not the right candidate, we need to start with 1. But with 1, we have already skipped one palindrome by not putting 0. So now we need to find out the third palindrome. Now if we put 1, how many possible palindromes are possible? 1, right? Only 1, because there's nothing to be filled afterwards. So with 1, only one palindrome is possible. But we need to find the third one. So again 1 is not the right candidate. So we will remove 1 and we will try 2, and we will subtract 1 from here again, because uh, we have skipped one more palindrome. Now we need to find the second palindrome. With 2, only one palindrome is possible, because there is nothing more to be filled. All the digits are already filled. So, uh, but we need to find the second one. So again, 1 is not second, like we can't match with 1. So that's where we have to, like 2 is again not the right candidate. We can try the next higher possible value, but before this, we have to subtract 1 from here. So we need to find the first palindrome now, and next digit is 3. So if you put 3, this is the only one palindrome which is possible, and we need to find the first one only. So 3 is the fixed. Now after doing this, we will just replicate this on the right hand side. So the next will be 3, 3 and 3. So hope the approach is clear. Now before jumping to the code, let's try to analyze the case where n is not even. So basically the length of like the length of string is not even. So let's say the length is odd. we what we are saying is this is exactly equal to the length 6. The reason being, this position is again an independent position. Like this position can also have anything between 0 and 9. So this position is an independent position, and hence we can just apply whatever we are following for 6 and just replicate to the right and then drop this digit. Okay, so hope it makes sense. Now let's look at the code. The code is simple, like we are just finding out number of positions to be filled. So if you remember, for even there is exactly length by 2 number of positions to be filled, but for odd we are taking one more position, so that's why I like length plus 1 by 2, so that it will give us the number of positions to be filled. Now for each position we are determining how many possible like how many positions are left on the right side. So uh, if you remember previously, we have tried this. So we are like every time we are putting something here, we are trying to find how many more palindromes can be formed. So for this we need to find out the number of positions that are left. So that's what left is. Now after finding left, we are calculating the number of possible palindromes, which is nothing but 10 to the power of left. And now we are trying digits one by one. So as we have discussed, if it is the first position, we can't put 0, otherwise the starting digit is 0. So we are trying everything one by one. So let's say we try the first digit, and if it is under this so there can be this many palindrome that is possible, and you have to find this palindrome, like kth palindrome. So if it is within this range, we will just populate the current digit in the current position and break. Otherwise, we have already skipped this much palindrome, because we are saying with every digit this many palindromes are possible. So we will skip this much palindrome and continue the loop. After breaking from the loop, if we find that current digit is not filled, it means the number of possible palindromes, like we have evaluated all the possible palindromes, and there is like the question asks for more palindromes. It is very similar to what we have discussed for length 2. So with length 2 only 9 palindromes were possible. With length 2 only 9 palindromes are possible, but if question asks for 19th palindrome, we have to return -1, right? So that's what this if condition is handled. So basically, if we have evaluated all the possible palindromes for current, like we have evaluated all the possible digit for the current position, we will just simply return -1. Now after doing everything, we have all the possible positions filled. So we will just convert it to an integer and return. So convert function is very simple. It is just converting this array to an integer and returning it. And in the main, we are just calling the same function for each query. So hope the solution is clear. If you have any doubts, please comment them below, and I will see you next week. Thank you.